All right, welcome. So if you notice, I am in a little bit different background here. I am actually in my classroom today. And the reason why I wanted to go for my classroom rather than where I have previously been live streaming is it's just a little bit easier. I have two young girls, both under the age of 2, and trying to fit in live streams, even though I like the 8 o'clock, kind of like 9 o'clock live stream, with doing everything that we got to do to get the girls, in bed, and then all the math work that, homework and grading that I have to do at night. It was just kind of a little bit harder. So my new kind of format that I want to kind of test out here until the end of the year is to try doing some live streams here right after school, because at least I'm already ready, in my classroom, got everything. So I kind of moved in my studio, moved my lights and microphone over here, and just brought everything in to kind of do the live stream. So I'm going to kind of do the same format here to kind of get started. I do have some other ideas for some more live stream content, but for right now, I still kind of want to get some content out there and obviously work on my pen marking skills. So I'm just going to kind of work through the homework that I assign my students. We're working in vectors. So if you are in pre-calculus or something working around the vectors, working with vectors, then this is just a kind of nice little introductory kind of video that I'll have for you. And then after I'm done, which I think there's only like 7 questions, after I'm done, then I'll be more than happy to try to answer any questions you guys have to kind of see how long this stream can go. So let me just go ahead and switch over here to my thing. I see already some people are in. So before I get going, hey Nun, hey Soroa, Best Football Edits, Ariana Gomez, Sharon Smith, thank you guys for joining. I hope you guys enjoy. So I'm just going to kind of work through this, get right into it. And then again, if you guys have questions or if you want a topic for me to kind of touch on, please feel free just to kind of go ahead and comment, and then I will get this going. And as far as also the days, a lot of people, kind of ask me, when are you going live? What are you trying to do? And I kind of took a step back because we had spring break and I had family in town. But I'm thinking that, kind of Wednesdays and Fridays kind of fits my schedule around this time period. And then obviously if I go live at different times, which I, plan to do, you never really know, you can obviously always hit the notification bell on my channel, and that will obviously tell you when I'm going to go live next as well. So, all right. Thank you guys for joining here. I will, you kind of think of it as like a little office hours. That's kind of exactly what it is. And I'll try to clean up my background here. I just got a whole bunch of math books, but I have other cool things that tell you a little bit more about me than math, obviously family and other things I enjoy. So I'll try to clean up my backstage, kind of make it a little bit more personalized here for the live stream. But for today, I really just wanted to check out my setup, see how it's going to kind of work, and see if this is something I can do moving forward. So, all right, the first kind of question that we worked on is question number 7. And basically what we're doing is we're working with a vectors. And the vector that we have is QR. Ooh, that was a really straight line. That was pretty good. So in this case, we have Q was going to be equal, or Q is given to us, and Q is at 3, 4. And then R was given to us at -2, 5. So I think the most important thing to kind of remember when we're dealing with our vectors in this case is, remember, a vector is a directed line segment. So it's going to have a direction and it's going to have a magnitude. Now, when looking into writing the vector, and actually I'm trying to find the component form as well as the magnitude. So the component form is just a really nice way of writing the vector, and it's a nice way of writing the vector when the initial point, or what we call the tail, is at 0, 0. So the first thing to kind of make sense of that, this is question number 7. To make sense of that, we can just go ahead and plot these 2 points, because these are coordinate points, right? The parentheses and the x coordinate and the y coordinate. So 1, 2, 3, 1, 2, 3, 4. That's our point Q. And then at R is going to be -2. And let's see, we're going up to 5. And again, the important thing about the vector QR is it's starting here at Q, and then we're going to R. And then we just kind of put a little arrows. But notice we kind of put the arrow to the dot, because it's not it is a ray, but it's like really a directed ray, right? It's a directed, or not a ray, it's a directed line segment. So it stops, it doesn't continue indefinitely. But it is going from Q, where it's starting, and then R, where it's ending. Now, this is not a bad one, but again, if we can find the component form, which is basically to write the component form of any vector when given the initial and the terminal point, basically all we want to do is just find the difference in the x position, which would be x2 minus x1, and then find the difference in the y position, or the second component, which would be y2 minus y1. And what I did in class is, we kind of looked at this as far as finding triangles. If you guys remember how the distance formula is related to the Pythagorean theorem, and that's really the exact same thing we're doing here. We're basically just go ahead and finding the distance horizontally as well as the distance vertically to write it in component form. So x2 minus x1, so if I get into this, so we can label this, since this is, since q is my initial point, I'll label that as x1. And since, so therefore this would be y1. And then I'll label this x2, and then I'll label this y2. And again, it's just an ordering kind of thing. It doesn't really matter how you order them, but we want to go from, we want to subtract the terminal point from the initial point. So let's see here. I have -2 minus 3, comma, and then I have 5 minus 4. Okay, so now when I go ahead and complete -2 minus 3, you owe me $2 and you borrow 3 more. Therefore, you're going to have -5, and then 5 minus 4 is going to be 1. So now what we can do is we can plot this point, but again, it's a vector, it's not a point. But let's just plot the point here real quick. So -1, 2, 3, 4, 5, and then up 1. Now, what you'll kind of see here, kind of like that. What you'll see here is the vector QR kind of got transposed. So now the initial point is at 0, 0. And that's basically our component form. It's the exact same vector, has the same length, has the same direction, but now it's being transformed to 0, 0. And that's just going to make our work a lot easier. So all we're really doing is when we're given the initial and terminal point, finding those differences in the x and the y values gives us the same vector, but with an initial position at 0, 0 at the origin. The next thing it asks us is to find the magnitude. So the magnitude is really like, if you were to think of this as a triangle, the magnitude is really going to be the length of the vector. So we could think about this as using the Pythagorean theorem, like we say this is 1, 2, 3, 4, 5. This is 1. We could also use the distance formula, which is basically this formula right here, and take the square root of it, except you got to square the terms. X squared minus x1 squared plus y2 minus y1 squared. But so in this case, if I just want to find the magnitude, I'm just going to go ahead and, now we have a different notation for magnitude. The name of my vector is QR. So I like to use the kind of double lines here to represent the magnitude. And again, I can just kind of think about this as Pythagorean theorem. So I'm just going to do 1 squared plus 5 squared. And therefore, the magnitude 5 squared is 25 plus 1 is 26. I cannot simplify the square root of 26. So I'll just leave my answer like that. Okay, so therefore, there's the magnitude, guys, and there is the vector in component form. All right, let's go ahead and work on question number 13. Let's go back to black. Question number 13 is given U is equal to -1, 3, and V is equal to 2, 4. Let's go ahead and just do a simple one. Let's just find the resultant vector of 2 plus V. So when we're adding the vectors, I'm not going to get into the graphical let's basically go into the graphical representation. So real quick, just to I'll do this for the first one, but I won't do it for the next one. So if we're looking at our two vectors here, we have vector U is -1, 3. Now again, notice how these are in component form. So that's -1, 3. That's vector U. And then vector V is at 2, 4. So let's do that in purple. So 1, 2, and then up to 4. So we have our two vectors, and if we're basically adding them, the way that we can think of adding them is to do what we call the tail to end method. So when you have a vector, this is what we call the tail, and this is what we call the head. So when you're adding them, basically what you're doing is you're just taking the tail of your second vector and adding it to the head of your other vector. So basically from here, I can follow this same kind of components here, and go over 2 and then up 4. 1, 2, 3, 4. And you can see that V here is, I mean, those are supposed to at least be kind of the same points in there. But you can see like these are supposed to be like parallel lines. So this is the exact same vector. Now, as far as mathematically or as far as algebraically, it's pretty easy to go ahead and add them. When adding two vectors, u plus v, all you're simply going to do is combine the first two components of each vector, so -1 plus 2, and then add the y components, which is going to be 3 plus 4. Okay, and when you go ahead and do that, then u plus v is equal to 1 comma 7. And then if I was going to graph 1 comma 7, take a look at this. I go over 1 and then up 7. 1, 2, 3, 4, 5, 6, 7. It takes me to exactly where the tail to end method graphically looked at. So obviously this is rather easy and you can kind of work it through there, but I wanted to kind of see you for that addition because that's kind of helpful, and sometimes you might be asked to graph it. It wasn't asked to graph, and I don't expect my students in this homework to be graphing them, but it is something kind of important. So the next one I'm going to get into is question number 13, which was, question number 18. Now, one thing I'd like to ask you guys is in the kind of comments below, can you kind of let me know what you would like to see out of my live stream? So as of right now, I've really just kind of thought about my live streams being, working on some homework and then asking some questions. I've kind of been hesitant to really go into like a full office hours and, just asking questions because I want it to really kind of be conducive to, many people. So I want to kind of, label a topic that I'm going to cover and then obviously at the end answer questions. So therefore people know when they're getting into live stream, is this something that I'm looking for or not? And then obviously if they have a question, I'll try to answer to them. If I go into a just general Q&A kind of live stream, it could just kind of be all over the place based on the kind of questions. So, but, I kind of want to hear from you. What would you guys like to see? Would you like me to kind of work over some of my documents or work over, some of the homework or some things I'm working on and then do some Q&A? Or maybe not even do Q&A at all. I don't know. Kind of let me know. I'd like to kind of hear what you guys, thoughts are, or what maybe I can bring better value to you as far as doing the live stream. Because I like doing the live stream. It just got a little tough doing the live streams at home because, as I mentioned at the beginning of this live stream, there's just so many things that were going on. And, we just had our second daughter in December. So, we're trying to put her to bed. She's crying. And then my wife's, nursing her and everything. It's like, and then I have homework and then I have like a quiz I got to grade before the next class period. So I'm up to like 11 o'clock at night. And it was just like kind of crazy. So I like to kind of do this after school. And I think that's kind of works out well. All right, so I'm just going to get into the algebraic portion of this. If I want to go and do this, the main important thing here is, first thing, instead of subtracting, which we can do, I recommend rewriting this as an addition problem. So we could say 2u plus -4z. So if you write it, because you can write any subtraction problem as an addition problem, this is just going to make your math a little bit easier because now all we need to do is figure out what 2u is. And 2u is when we have scalar multiplication, you're just multiplying the scalar times both of the terms inside. So that becomes just a -2 comma 6. And when I do -4v, well, I'm just going to distribute again the -4. Distribute the -4. Oops, I wanted to both my components on the 2 and 4. So that's going to equal -4, 2 comma 4. Okay, so now when I go ahead and distribute that, I get -8 and -16. So now I can basically just combine these two vectors. So now I can just add them because I already found 2u, which is right here, and I found -4v, which is right here. So if I'm just adding them, then it's just like the last problem I just did. All I simply need to do is go ahead and add my first component, components, and add my second components. So I'll write my answer as 2u minus 4z. That's equal to -2 plus -8 is -10. And then we're dealing with 6. 6 plus -16 is going to be -10. There we go. Let's work on. Next one is question number 25. Let's see what question number 25 was. I kind of forgot what I assigned here. Oh, okay, so now we're given a vector 2, 1, and we need to find the unit vector. Unit vector. We haven't talked about that yet. So let's go and take a look at this real quick. Let's say we're going to 2, 1. So here's my vector 2, 1. And we could, write this. This is vector, labeled vector u, and they're asking us to find the component form and then write it as a linear combination. Okay. So here's vector u, and if we were going to look at vector u is 2, 1. Now, if we were to kind of think about this as like a triangle, you could say that's 2 and that's 1. And the hypotenuse, by using the Pythagorean theorem, 2 squared is 4, 1 squared is that's going to be square root of 5. So right now, my magnitude of u is equal to 5. Now, just think about it. If I want to make the magnitude 1, because that's what the unit vector means the magnitude is going to be equal to 1. So if I want to make this magnitude equal to 1, all I simply need to do is divide by 5, right? And that's the definition of a unit vector. Usually we use u to use the unit vector. But the unit vector is simply just the vector, let's just take the vector u divided by its magnitude. So in this case, my magnitude is 5. Well, my vector here, oops, I forgot to finish that vector, is 2, 1. So now simply what I'm going to do is just take my vector. So if I want to find the unit vector, so my unit vector, sorry, my handwriting gets a little stalled. Let's try maybe writing up a little bit higher. So my unit vector here is now going to be my vector 2, 1, all over the magnitude, which is 5. And the hard thing about this, a lot of students get confused or struggle with the division property of this. But just remember, guys, we can rewrite this as 1/5 times 2, 1. And since now we can see this is the same thing as scalar multiplication, so now my unit vector, if we just distribute this, is going to be 2, 5, 1 over 5. So it's really kind of 2/5 over to 1/5. So my unit vector here is going to be, let's see, it's a very small, it just got reduced. It's kind of like that big. It's like very, very small in this case. And that has now a, well, it probably should be around there, right? Yeah, probably something like that. Not there. So anyways, the vector is going to be around that size where that's like, 2/5, and then this would be, roughly 1/5. And again, this is all roughly. Now, the next thing is it says for us to write the vector as far as linear combination. And linear combination basically is just our way for us talking about unit vectors in the horizontal and vertical realm. So if we have a unit vector going vertically or horizontally, we give that the denotation I, and our unit vector going vertically is going to be j. So you can see that here, this is 2/5 of I, right? It's not totally a horizontal unit vector. So to write this in as a linear combination, I'm just going to write 2/5 I plus 1/5 j, because it's 1/5 of j and 2/5 of I, where j is the vertical unit vector and I is the horizontal unit vector. All right, guys, I got one more problem to do, and then I will get to kind of any of your questions I got here. So the last one is 26, which is the exact same thing. So this one gives me the vector u, which is -3, 2. Okay, and then again, what we want to do is go ahead and find the magnitude of this. So to find the magnitude of u, that is going to be square root of -3 squared plus 2 squared. And that's going to be 9 plus 4, which is 13. And then I'm just going to take my vector u, and I am going to divide it by its magnitude. So I'm going to take -3 over 2 divided by square root of 13. Now we're going to distribute this. You could rewrite it like over here we did, or you could just distribute it. And we don't need to rationalize the radical like we've previously done for a lot of other algebra topics. That really doesn't give us any simplified form of this answer. So we just write it just like that. So there you go, ladies and gentlemen. That is kind of it. I would love to kind of answer questions. I'm just going to kind of work through this. Hopefully you guys kind of gave me some things to, kind of ponder and, look at. And I'd be love to answer any of your questions. So let me kind of scroll to the top, and then I'll just kind of get to this. Marissa Lusky Nut, thank you very much. Hello, please, Telegram, WhatsApp. Find your videos. Asra, very happy to be able to help you out. And let's see, nice office. Thank you very much. I appreciate it, Ayana. Thank you. I'm just happy to really be able to kind of share the love with math and get you guys going into there. Please teach area vectors. Well, we're kind of just getting into the introduction right now of vectors, but I will be getting into some more stuff. Parallel, hi doctor, I'm not a doctor, but I wish I knew. What is a unit vector? Looks like I got in there. So anyways, guys, I'm getting to the end. Can we do word problems with vectors? Yes, I can do a word problem with vector. I can do one of them. This is one thing actually I gave to my students, so I can go over that problem. It's a relatively simple problem, but I'll go over it. But real quick, just to kind of answer your question, Mohammed, as far as like what is a unit vector? Again, a unit vector is all it is a vector that has a magnitude of 1. So what I kind of example I did in my class yesterday is I did the vector 4, 5. And if we were to kind of think of this as like a triangle, well, then this would be 4. Actually, I didn't do that. I did 4, 3. So if we were to think of this as a triangle, let's go back to wrong purple. Well. Therefore, this would be 3. Now, hopefully you know that this is the Pythagorean triple, so you know the magnitude is going to be 5. Let's call this vector v. All right. So if I wanted to get this magnitude to be 1, like get it like right here where the magnitude is 1, what do I need? Basically, what can I, how can that happen? What do I need to do? Well, if I divide every single one of these terms by 5, then I'll have a unit vector because 5 divided by 5 is 1. And then now I have 3 divided by 5 and 4 divided by 5. So now my new unit vector, if v is 4, 3, then u is going to be 4 over 5, comma, 3 over 5. And that's just a unit vector. And the main thing really that you need to know about the unit vectors is going to be that the magnitude of a unit vector is equal to 1. And that's really the really helpful thing that we kind of do with that. Jonator, get spammed. Okay, I'm seeing red dots. I'm not sure what you have. Michael, all right, let's go ahead and do a word problem for you. I actually have one right in front of me that I kind of did. And actually, I did this one in class. So let's go over this one. So in this one this word problem says a force of 50 pounds acts on an object at an angle of 45 degrees. A second force of 75 pounds acts on an object at an angle of 30 degrees. So basically what we have here is we have an object. And on that object, we have 2 forces that are acting on it. And they're giving us degrees. So therefore, I'm going to probably want to draw a coordinate grid to understand the degrees. All right, so the first degree is acting on it at 45 degrees, and it has 50 pounds of force. So I'll just do like a 45-degree angle here. And 50 pounds, well, remember, when we're talking about vectors, vectors have a direction. So we have here, we're going that way. But they also have a magnitude, and they say it's pulling with 40 pounds. So LBS. So that's going to be that's going to be your magnitude of your vector. The other force that's forcing on it is at negative 30 degrees. That's at negative 30 degrees, and that has a force of 75 pounds. Okay, so basically what they're asking or what they want to find is what is the resultant vector? Like when we keep on pulling both of these, where is this vector going to be going? And or what direction is this object going to be pulled into, and as well as at what force? So I think we can just kind of like hypothesize here that if I'm pulling an object this way at 50 pounds and this way at negative 30 pounds, well, this force is much stronger than that force, right? Now the angle is a little bit more stronger here, but if I was to look at this, since this angle is a little bit stronger, I'm thinking, I don't know, that the object is maybe going to go in that direction, like right there, right? It's definitely going to go to the right, right? Your object's not going to be pulled to the left. You have 2 objects One's pulling up, one's pulling down, but they're both also pulling to the right. So what we're going to want to do is we're going to want to create a vector for each of these forces. So let's call this vector V, and let's call this vector W. So if I'm going to represent vector V, now the important thing is there's another form of vectors that I didn't discuss at least today. So here's your component form, right? Well, another way to write a vector is when we look at the unit vector. I don't want to get too much into this, but when we look at the unit vector, we could think about the unit vector as like on the unit circle. That's going to have the since it has the hypotenuse of 1, we could represent the first component as the cosine of theta and the second component as sine of theta. So just remember, here's your unit vector, right? 1. Well, remember from the unit circle that is as long as the radius is 1, then you can represent your endpoints as cosine theta, sine theta. Now, when my magnitude changes, that's basically like the radius changing. So all you're doing is multiplying it by its magnitude. So we can say the magnitude of V times the cosine of theta, sine of theta. And now you're going to make me have to go and grab my calculator. But anyways, so let's go and talk about vector V here. So vector V, I'm going to want to use this formula. The magnitude is 50. And then I'm multiplying that by the cosine of 45 degrees and the sine of 45 degrees. Okay? And again, now this distributes. So again, scalar multiplication here. So we're going to have 50 times the cosine of 45 degrees and comma 50 times the sine of 45 degrees. Okay? So now what we need to do is go and grab our calculators, which I don't think I have my calculator with me. I'll go right over here. Oh, I guess I could have. Oh no, I deleted the software off my Mac. Never mind. I used to have a calculator function up on there to show that, but maybe once I upgrade my computer, I'll put that back on there. So just make sure your calculator is in degree mode. And when you go ahead and type these in, I'm just typing 50 cosine of 45 degrees and then 50 sine of 45 degrees. All right. So that's going to be those are your two vectors. Actually, I'm not even going to, why am I solving those? I don't care about that right now. Let's go and talk about vector W. Sorry, we'll get to that in a second. So vector W is going to be the same thing, but now we have an angle of negative 30 and a magnitude of 75. So rather than going from this step to this step, I'm just going to write this as the magnitude times the angle. So this is going to be, just to save myself some time. So I have 75 times the cosine of negative 30 degrees, comma, and then I have 75 times the cosine of negative 30 degrees. Okay, so again, what we're looking for is the resultant vector. So our resultant vector is basically just going to be the sum of these two vectors. So that's what we need to figure out, is what exactly is the sum of these two vectors. So I'll write it out, but I'm going to do the math, obviously, in my calculator. Oh man, my hand kind of hurts writing all this stuff. It's not very fun using this tablet. I'm not used to this. I much wish I could have used a pen and my iPad, but whatever. So anyways, what I'm looking into doing now is I just need to add my two components here add my first components and then add my second components. So I'll do 50 times the cosine of 45 degrees, plus 75 times cosine of negative 30 degrees. So that's my first component. And then my second component, hopefully I have enough space in here, I guess I'll write this a little bit smaller, is going to be 50 times sine of 45 degrees. And then that's plus 75 cosine of negative 30 degrees. Okay. Now we can go ahead and do that in your calculator. And so I'm just going to add those all together. So 50 to cosine of 45 plus 75 cosine of negative 30. I'm going to round to the nearest hundredth. So something's wrong. 50 cosine of 40, cosine of negative 35 degrees. What did I do? What did I do? Something is wrong. Did I change my, no? Okay. Oh, I see. I didn't use my parentheses. 50 times cosine of 45, end the parentheses, plus 75 cosine of 30. So if you don't use your parentheses, you got to be careful. That comes into 100.31. So R is equal to 100.31. And I'm just rounding to the 10th. And then the next one is going to be 50 times sine of 45, end parenthesis, plus 75 times cosine of negative 30. Oh, that's supposed to be sine. Jeez. Anybody else notice that? Did I not write that in there? Well, somebody caught it in the chat. Good catch. I did not catch it because I was just talking. So I didn't do mathematical. I'm just going to, fortunately, I didn't do any math or terms with that. So sine of 45 degrees, end parentheses, plus 75 sine of negative 30. And I get negative 2.14. Negative 2.14. Okay, so if that's 50 and that's 75, let's actually see what the answer ends up being. So the answer is like 100, so, and it's at negative 2.14. So that's just below the horizontal. Okay, so in this case, the 75 pounds really had much more of a forcing act on this vector than the angle. So, you know, I was in the relative position, but I was a little off. But the answer at least makes sense. And there you go, Michael. That's at least a word problem for you. I hope that kind of helped. Let me see. Soraya has another one. How do you find the combination of quarters and dimes? This is 9th grade math, by the way. Thanks, Jenator. I really appreciate you joining in the conversation. You are happy to provide great comments here. That's awesome. Let's see here. No, well, let me do that. No, okay. I'm trying to look up my thing. Guess I'm not getting that. Okay. Let's see here. LOL, you're salty. Thank you very much. I don't know what you're talking. Yeah, I know. I don't know. I don't get it. X plus Y equals 80. C plus D equals 11. I'm not sure what you're trying to do. You have 4 equations, and therefore 4 equations looks like you're going to need 4 different variables. So I asked, do you know how to solve this word problem? You have 80 coins in quarters and dimes. The total change is 11. How would you find the combination of quarters and dimes? This is grade math, by the way. I remember teaching grade math 9, and I remember doing these types of problems. So let's see here. You have a system, so you're going to be using systems of equations. Let's see if I can remember this here. So you have a total of 80 coins. So first of all, let's say Q is going to represent our quarters, and D is going to represent our dimes. Okay, so based on the information you're giving me here is we have 80 total coins. So therefore I can say that Q plus D, all right, write that as a D. Q plus D equals 80. All right. And then the next one you said is the total change or the total amount that you have is $11. So we need to be able to say, well, how could we represent that? So we don't know how many quarters are in there. We don't know how many dimes, right? But we know that a quarter is worth 25 cents or 25 cents of a dollar. So 25 cents so however many quarters we have, you're going to multiply that by 25 cents. That's going to tell you, how much money you have. plus a dime is 10 cents of a dollar times d, and that equals 11. Okay, so basically what we're going to want to do here is write a system equation, and I don't know about you, I do not want to be working with decimals. So the first thing that I'm going to do is I'm going to multiply this whole equation by you would think about doing 100 would kind of make sense, but I'm actually not going to do 100 because what I want to do is I want to go ahead and solve for d, or I'm going to have to use substitution or elimination, right? Actually, we can do it either way. Let's do it by 100 and then see make sure we get the same answer. So if I multiply everything by 100, 100 is going to get rid of my decimal places, right? So you multiply everything times 100. So by multiplying everything by 100, you get now a new equation, 25q plus 10d. Oh, I didn't want to. No, I just want to multiply by 10. That's right. Let's not do that. Let's multiply by 10. If you multiply by 10, you could do 100. There's nothing wrong with that, but we're making our lives much more difficult by multiplying by 100. So if I multiply by 10, then I'm going to have 2.5q, which might look, oh, that's looking more confusing from the start. Plus, however, this is only going to move over one decimal place, right? Multiplying by 10 is really just moving over the decimal point. So therefore, that's going to be 1d, which is really just d. And then 10 times 11 is going to be 110. Now, this is important because we could do two different ways. We could do substitution or we could do elimination. In this case, let's do elimination. So I'm going to take 2.5q plus d is equal to 110. So now what I need to do is I need to eliminate these variables. Well, you see that d's are both positive, right? So if I go ahead and subtract them, then I have q, which would be like a 1, minus 2.5, which is going to give me a negative 1.5. D minus d is going to be 0d, which is just 0. Sorry, that's q. Equals 80 minus 110, which is going to be a negative 30. Now, 1.5 might not be the easiest number to kind of work with, so you could also think about this as I could divide by a negative, and then I could rewrite this as 3/2 q equals 30. Okay? Now I can multiply this, so I can multiply by 2 on both sides. So when you multiply by 2 on both sides, I get 3q is equal to 60. Divide by 3, divide by 3. Q is equal to 20. Now that I know the value of q, I can go and plug in my value of q back into my equation. So I could say q plus d equals 80. Plug in the 20 for q plus d equals 80. And then subtract the 20 on both sides, and d equals 60. Therefore, since this is a word problem, I would write out, you would have 20 quarters and 60 dimes, and that's basically what I would go in for you on that one. So hopefully that helps. Oh, you're going to super chat, Jenator? You got in the super chat? If I say I hate math. No, seriously, I do hate math. Actually, I don't think I ever told. Well, if you guys have any more questions. Now, Jenny, if you want to super chat, that's fine. I don't really care if you super chat or not. That's not why I am on here live streaming. But if you want to super chat, more than welcome. But I do want to let you guys know that kind of story because all my questions run dry. Nobody else has asked any questions. So I'll answer maybe a question if I can. Can you introduce polar coordinates? I can. I'm not going to do them today because I am at the end of my live stream. But I will be getting into that next week. So if you check in for my live stream, which I will be doing next week, I will get into polar coordinates. We're going to do parametric, we're going to do polar, and all that kind of stuff. But I am kind of wrapping up this, so if I have anything on vectors, I'll kind of stay on point, but I will be getting into that. So sorry, Kalash, to kind of say I was going to do that or answer any other questions, but to kind of stick on point, or at least to wrap things up here, because I am getting at my 45-minute mark for my live stream. I'm just going to kind of keep them in. Well, you know what? Let me not be so mean. Let me get a little bit in there. But anyways, going back into my I hate math comments, math is not really something that I was good at in high school. I didn't really like it. Actually, I hated it a lot. I'm not sure if I've, mentioned a lot, but my mom was a math teacher. So, she kind of like, a lot of people think, oh, that'd be great. Like I always had a resource, but she always wanted me to learn stuff. And I didn't really want to learn really math. I just wanted a grade. Like I really just cared about getting a grade. I didn't really care about learning anything. And she always, wanted me to learn because that's what us math people, like we want people to like have a true understanding, like, because that's the beauty of mathematics. It's not, oh, just do this and go ahead and get a grade for it. So anyway, I didn't really like math for the longest time, and it wasn't until really my college years that I really started to fall in love with math because we started to branch out of more of just doing math problem. And that's kind of the unfortunate thing about my education was, a lot of it was this old school math. Just do math problems. You didn't really need to understand why or what you're doing. You just do the math problems. And of course, that doesn't really serve you very well in real life. And you kind of like don't really like, I still appreciated math, but I didn't really love it. And it wasn't until I got into upper level math classes that I really started to appreciate math and then gain a passion that I want to kind of share with others. Anyways, class, I'll just give you, introduce polar coordinates just real quick. So here is what we call the unit circle, right? The unit circle has a radius of 1. So the only thing you really need to understand, like, so here, like, let's say this coordinate here. Let me go and look at it in. So let's say that coordinate is, let's do a big unit circle. Let me move this over. Just want to make sure I'm able to see it. Okay. So if I do a big unit circle, all right, so here's the big unit circle. Let's do it 45 degrees. Okay, now at 45 degrees with the radius of 1, all right, we know this coordinate point is square root of 2 over 2, comma, square root of 2 over 2, right? And that's on the coordinate grid. Now on a polar coordinate, it's still the coordinate grid, but rather than worrying about the y-axis and the x-axis and like the integers and what they go through, we can graph this exact same point by knowing nothing more than the radius, which is 1, and the angle, which is 45. Because once you say that square root of 2 over 2, that is how, because basically what that means is that's how far you're going to the right, which is square root of 2 over 2, and that's how far you're going up, which is square root of 2 over 2. But another way to represent that is in what we call polar coordinates, which I'll go into more detail later, but at least the roundup, is r, comma, theta. So the polar coordinate kind of looks like this, where each kind of circle represents a different radius, and then obviously we have our angles that we've talked about in trig. And so you can go between polar coordinates and rectangular coordinates just by converting them. So there's kind of your basic on there. All right, guys, I'm just gonna wrap everything up. I do appreciate you guys joining in for my kind of upload, and I still would appreciate if you guys want to, message me or just comment, kind of what you think about the live stream at this time and in my classroom, kind of see how everything kind of fits. It's different than what I've been doing before when I was trying to do it on like Monday and Tuesdays at 8 o'clock at night. So just want to kind of see if that helps. And then also, what are some things you'd like to see from me on my next live stream? Because I am going to be wrapping this up. Ryan asks, do you do online tutoring? No, at this time, Ryan, I am completely full with teaching my own classes, and as well as creating a lot of stuff that I still do for my class, as well as online content, preparing for my additional videos I make in addition to my classroom videos. And then obviously having a family at home, kind of, I don't really start to work until like 10 o'clock. So unfortunately, I just don't have time for any kind of private tutoring, but I do appreciate you asking this. Could you do magnitude over vector in surd form? Well, unfortunately, I just got to wrap this up, and I appreciate all you guys. Yes, thanks. I'm going to screenshot this. What are you going to screenshot? Oh, well, you guys can, I got to figure a way. I might be able to, maybe what I'll do is looking to print this out and then adding this document in the description. Do you guys think that would be helpful? If I kind of told people, hey, the link to my answers, or at least what I went over, is in the document below. I do have some worksheets that I want to go over, and I'll provide the blank copy as well as the downloadable copy. Let me know if you think that would be something handy. So therefore, you could kind of do the worksheet on your own and then check your answers with me. And then obviously, if it didn't make sense, you could go ahead and watch the video if you want to, because I don't think always times you're going to want to always watch the video. But all right, guys. Well, that is it, and I appreciate you guys joining. Right now, I'm thinking I'm going to be out of town on Friday, so I'm not sure if I'll be able to do another live stream on Friday. But moving forward, at least till the end of the year, you guys can look forward into checking my live streams on Wednesdays and Fridays around like 3 o'clock. And I'll do my best to get a reminder out there. But as always, if you want to get a reminder, just go and hit the bell notification, and you'll be reminded by the next time I go live. All right. See you later, guys.